Yeah. All right. So hopefully we have audio. Otherwise, bad things will happen. But we'll find out. People will complain. Um,
Perfect.
all right. So who wants to get started?
Well, either me or Prashant.
Yeah.
All right. So hopefully we have audio. Otherwise, bad things will happen. But we have audio in two places.
Yeah.
We'll find out. People will complain. Um,
Perfect.
that's not me at this point. I think is it?
I'm just waiting for the.
All right. So who wants to get started? Whose audio is that?
Well, either me or Prashant.
Yeah.
All right. So hopefully we have audio. Otherwise, bad things will happen. We have audio in two places.
Yeah.
We'll find out. People will complain. Okay, that's too many browser windows here.
We're gonna learn about recursion first.
This is funny.
How long until we overflow?
Ah.
I was just amused that a question was asked and the audio stream provider.
All right.
Probably not the right answer.
All right. Unmute yourself. Whoever wants to talk.
Okay, cool. So probably you should do the first, probably the most controversial thing first, which is the namespace and the name of the type.
Yeah, there goes
The rest
2
of-
hours.
The rest of it is not. The rest of it should be fairly easy.
Maybe it would help if we like set the background or describe like what this thing is, right?
Oh, okay. So if people are familiar with pandas, then this is like a .NET equivalent to pandas. For those who are not familiar with pandas, what a data frame is basically tabular data that is in memory, but you can execute operations on it. So like a binary operation on it. So you can do like column A plus column B would give you like column C, right? And in this space in .NET, because we're so strongly typed, well, before that, each column can only have one type of data, so it can be like int, floats, doubles, whatever. The data frame has a backing store in the Apache arrow format, which means it just stores bytes at the back, and there's like a standard representation for the float and int and blah blah. Which means that if you have a column of say ints and then you add a column of float, the result the compiler knows is a float. But because so you need to make a new column. You cannot like update the int column itself with like Inplace because the byte representation will change, right? So that's kind of one thing to keep in mind as we go through the APIs. The other thing to keep in mind is this is mostly at the moment being used in a Jupyter notebook. So for most operations, you would expect a copy to be the result. In-place ops are an option for some APIs. Those are the major things we need to know. We can actually start looking at the API. And yeah, like I said, probably the most controversial thing we should get out of the way is like the namespace and the name of the type itself.
But is the feature general purpose or related to ML or to data space?
It's related to the data space. It's a way for people to explore a data set that they have. So if you have like a CSV of something, so you can import the CSV in a notebook, and you can explore the data. So for example, you can say like you have a column that you want to investigate. So you can do correlation of column A and column B, and so that would be like an API that like you have access to the column data, so you can write the correlation function, whatever correlation function you want to do stuff like that.
But it doesn't have any dependencies on either ML.NET or system data, correct?
Not on system data. From ML.NET, there's no dependency, no. It only implements iDataView, which is its own package.
Okay, so it's
it's independent.
it's related to iDataView.
Yes.
Is iDataView?
Right. We imagine DataFrame would either implement iDataView if we want to have a direct dependency on the DataView framework, or you could imagine like a to iDataView extension method in the future.
I see.
Today we just directly implemented iDataView because that seems like the most natural thing to do.
But iDataView is still just a NuGet package for ML.NET, it's not in the BCL, correct?
Correct. It's actually, yeah, it's a NuGet package, but it's separate from like the core algorithms
Yeah.
of ML.NET.
Yeah.
We separated iDataView out into its own NuGet package, independent of everything else in ML.NET.
So you mentioned
Here-
the backing store for the data. Is
Yeah.
that important to the data frame, or is that an implementation detail?
Important to the data frame because the backing store, that format is also kind of a protocol. So for example, if you're doing a Spark job, you get the data from Spark in that format. So when Spark gives you the data, you can wrap a data frame around it and use the DataFrame API. Does that make sense?
Right. It's important for two reasons. One is you can do zero copy
Right.
wrapping, but then two is we expose. You'll see later, but we expose APIs to get at the actual buffers, and so the arrow format is a columnar format, right? So all the data is stored in columns, and so the idea is you can do SIMD operations on this data,
Right.
which you couldn't do in like a row-based format, right?
Okay. And I'll also add one more thing, which is the APIs that it exposes are kind of grouped into like these major categories, which is binary operations, which is like add, subtract, multiply, blah, blah, blah. Computations, which is like sum, max, mean, that kind of thing. There's also joins, merges, and sort.
Can I ask a question? Going back to iDataView, so pandas allows random access, right? And iDataView, I think it's just a read-only forward kind of streaming cursor way accessing data. And so you were able to read, even though you based your storage on iDataView, but you were able to overcome this, so you can do random access.
We do random access. We don't base our storage on iDataView.
Oh, you don't. Okay.
A DataFrame implements iDataView, so it can provide an iDataView cursor over its data,
cool.
but all its data is in memory. It's holding in memory.
Yeah, thanks.
Cool. And the primitive types that the column can hold is like the primitive types that we have in C#, so like int, float, decimal, double. And then strings have two columns, a string column and an arrow string column. The arrow string column is immutable. The string column is mutable. So that's the whole range of data we can represent.
And are the transformations implementations of the ML.NET transformers?
No.
Why not?
So a couple of reasons. One is the ML.NET transformers are lazy evaluated, right? So like imagine you're replacing NA values with the normalized median or something like that, right? Like that doesn't actually happen until you loop over the data frame or the iDataView in ML.NET.
Yeah. Mm-hmm.
Where here in data frames, like they're eager, the operations are eager.
Right. And why? What's the, like, is it a conscious choice? It's better to be eager, like during the ML.NET design days, we concluded that lazy evaluation is better for large data sets.
It's better for large data sets that don't fit into memory, but kind of like a key part of this is all the data does fit into memory when you're using a data frame.
Eager usually is easier to debug and easier for developer, but non-eager mode, it's usually better for performance.
Right. And so these computations, right? Like if you say column A plus column B, you get back a column C. Well, column C, since its internal memory is in memory, right? It can't do like stream that data lazily.
But would it be possible, so even if we have those transformations that are eager, could they implement the ML.NET abstraction such that if I want to add two columns, I don't have to use two different transformers? I have a transformer that can be either in a eager or lazy mode.
Yeah, if you're buying into ML.NET, like using ML.NET, the data frame implements iDataView, so you can put ML.NET transformers on top of it,
Yeah,
and you'll just get back iDataView.
Yeah,
right?
yeah, I understand that I can do that because DataFrame implements iDataView. What I'm asking is, these transformations, can they be used in a context of ML.NET pipeline? And
Yeah.
I heard the answer is no, because they are eager. I'm saying, could we make them such that they are into modes?
I guess I understood the first question to be, can I use ML.NET transforms always in data frames? Like, do it on a data frame and get a data frame back.
I understand that this works. That's not the question. The question I had, can I use these
That
transformations?
doesn't work. That doesn't. What I just said doesn't work. If you take an ML.NET transform, apply it on top of a data frame, you don't get a data frame back. You get an iDataView back.
Yes, I understand.
Which is lazily evaluated.
But that's not what I'm asking. I'm asking, can I use these transformations, like you were talking about adding two columns and storing the results in a third column? Can I use these transformations in a context of ML.NET pipeline?
Yes. Well, you have a data frame, you do the transformations, you get a data frame, and then you pass that into an ML.NET pipeline.
No, that's not what I'm asking. Forget about data frame. I have let's say I have iDataView from ML.NET. I loaded CSV file. Can I apply one of those transformations like that? Or
no, because these are data frame APIs, right? You can't apply a data frame API on something that's not a data frame.
The underlying memory layout and data is different.
And so where are the operations here?
If you
can we look at some sample code? Do we have like a list of like high level stuff of what you would do and how would it look like?
Wait, Eric, do you have the
notebook? we have like a notebook. If you want to pull up a.
Actually, could you share your screen maybe?
Yeah, screen sharing will not work very well because nobody can see that because it has to be on my box. Can you just send me the link in Teams?
Yep.
I can just open that, hopefully.
Can you open that?
Let me click on that.
GitHub not liking to show that notebook right now. Sometimes that works, sometimes it doesn't on GitHub.
Can we look at the raw view? Is that intelligible or is that?
No, the raw view is not.
I guess the answer is no.
Something to do with total bedrooms.
Is there like within the sample something else we can look at?
We can look at the tests.
That would work for me. Is it next to samples?
No, that repo is a completely different repo. I sent you another link.
Oh.
Yeah, I sent you another link for the tests.
All right.
Yeah. Scroll further down, or tell you when to stop.
Go to the first fact, maybe.
Yeah, first fact. Yeah, further down. Yeah, that one. This one is a data frame of two columns, both having integer data. So this indexing, so for example, data frame 0, 0 means 0th row and 0th column. So that would be the first element in the table. 1, 1 would be like the next diagonal element.
Right. It's row, column, right?
Yes. So if you say head, that would mean the first 5 rows is what head gives. tail would give the last 5 rows. So the first, basically from line 170 to line 180, you're extracting data, so all the indexers are the get value indexers. Line 183 is a set value indexer. This means change the value at that index to like 1000. Let's see. Line 189, what happens there is DataFrame of int2 returns a base column. The derived type is primitive column of int, so that's what I'm doing. The reason that is important is primitive column of int knows that it holds integer data, so the APIs that you use, IntelliSense will give you that the return type is an int and the data is an int. DataFrame of int2, everything would be object because that's the base column.
So primitive column, is it a ML.NET iDataView type or it's your type?
It's my type.
So why did you need new types to describe the columns? Why not use the ones that are in ML.NET?
There's no type in ML.NET that's this type of.
What do you mean? There's
schema.
Yeah,
there's schema, right?
Mm-hmm.
This is data though. Primitive column is data. It represents data. So like data frame is columnar laid out, right? So if you have 5 columns, you have 5 objects that point to the data of those columns.
Yeah, so when you say data frame some name, you basically get the entire vertical slice of the table, basically.
Yes. Of the whole column.
Yeah.
Like int2 would, the name of the column itself is int2.
And then you can just index into
Yes.
rows. But so why not, when you get int2 column, the return type could be iDataView, correct?
Yes.
But then you don't have random access, is that?
Yes,
No,
it's only
wait,
sequential.
stop. When you say into column, you don't get it, like an iDataView represents multiple columns,
Right. No, we could make one.
Yeah.
You could make an iDataView that just contained one column in it?
Yeah, I think that's what he was asking.
Yeah.
But now, like,
But let me ask differently.
but it's a different concept, right? Like
Yeah.
it's just one column. It's not a whole collection of columns.
Sure. I'm just basically, so what I'm getting at is, it seems like we are on a path to end up with 2 slightly different representations for tabular data. And I think we all hope that iDataView would be the representation.
Well, I mean, it depends on how you see it.
I'm not seeing that exactly. Like, think of it like iList and list. Do you think those are 2 different representations of list data?
I think it's, the analogy is reasonable, but it's not perfect. I think because then you have, different way on operating. We are creating 2 different ways to operate on these tables of data, versus iList and list, you can both, like, common operations are done in the same way.
But we're doing that because they're different target use cases, right? Like, the iDataView it's extremely like the least common denominator of what a tabular data could possibly do, right? Like, by least common denominator, I mean it describes to you what the columns are, and it allows you to get a cursor, forward-only cursor over the rows, right? That's all you can do with iDataView. It's the only operations it can possibly do.
You pointed out that there are some flaws. I understand that. I mean, maybe not flaws, but
it's not that there's a flaw. It's not that there's flaws. Yeah. Like that's its only goal in life. Because the idea being, you can implement that with all sorts of different data, right? Some could come from Azure Blob Storage, from a file, from a database, all sorts of different places, right? Where a data frame is very opinionated about how its data is actually stored. And since it's opinionated about how its data is stored, it can allow a much greater range of operations on that data.
I think it would be good if we ended up with these two technologies being rationalized, and for somebody who wants to deal with tabular data, they looked like a single coherent feature with maybe different APIs and abstractions optimized for slightly different scenarios, but one feature. I worry whether we are not on track to kind of say, well, DataView has these limitations and ML.NET, we're gonna create almost like a, another take on it.
The rationalization is if your data fits into memory and you need to do in-memory type of operations against it, you can use DataFrame. If your data doesn't fit into memory, right, and you just need to stream it one row at a time, iDataView. And DataFrame implements iDataView, and so that anything that takes an iDataView, you can pass a DataFrame into it.
There is also another rationalization. iDataView does not provide random access. And the target goal here is to mimic Pandas DataFrame, which allows you random access. So you can access any data in any order you want. While iDataView, you have to go basically cursoring from the beginning to the end, all the time. There is no random access.
Can we see some operations like how?
Yeah, it's further down. Emo, can you scroll further down?
Like sorting.
Yeah, further.
There's a sort, right? There's a sort operation.
Yeah.
There's zero chance for you to do a sort operation in iDataView.
Scroll further down.
That's not what I don't think that is the goal, and I understand you cannot sort stream only APIs. I'm just saying, can we end up in a situation where to users who want to use any of these technologies, they basically appear as different features in a single technology, not two competing technologies?
But if DataFrame is already implementing iDataView, it's already implementing it. It is one. I don't understand your concern.
For example,
you can treat it as an iDataView.
For example, you apply operations to the tables differently.
Not if you only have it as an iDataView.
Yes, that direction is one way, but the other direction doesn't seem to be correct.
I mean, it's a specialized type that has specialized operations. That
Right.
I mean,
seems
in a
to be the
certain
purpose
way,
of
you
specialized types.
You could think of it as an array versus span, right? I mean, they're not all completely orthogonal. Right? One is a strict subset of the other, and so you end up with a world where certain operations just don't make sense. You have to layer it in terms of like a concentric circle kind of thing, right?
So let me, like, very concrete thing where I think there is a bit of a divide. We have been discussing namespaces.
Right.
Are these types gonna go into ML.NET namespaces?
I think the idea they should, right? In the same way that we didn't put iDataView in an ML specific namespace, right? The idea is that we kind of provide a more generic data thingy that makes certain things more easy to use.
I don't know. I don't think it should go into the same namespace.
My opinion, which I have a note here for when we get back to discussing the namespace, is if this is dependent on the Spark namespace, it needs a non-generic, the Spark data format, it needs a non-generic namespace. This is not data, this is Spark.
If it depends on it, yes. But my understanding was it wasn't depending on it.
He said it was very important to the format, that it's exposed in the format, it's an input type, it is very transparent over the Apache Spark stuff. That means this is Spark and not data.
Apache Arrow stuff, which is different from the Apache
Arrow.
Spark stuff.
Sorry. Something Apache.
Okay, yes.
There's a data format that this is entirely dependent on. This is just a representation of that data format. This is not data in general. This is Arrow or whatever it is.
Well, I mean, I would separate the particular implementations from the use cases, right? Like in the same way that data set had high dependencies on certain XML formats, but the question is, what interaction model are these things used in, and how are we promoting this? And my understanding is the way we would promote this is if you want to do something in an interactive fashion similar to a workbook style thing, then you basically have to think about what that means for the user experience, right? The fact that it also mirrors somebody else's format, I think, is not the high order bit at that point. It just becomes a what's the use case for the API, and does the namespace make sense for that use case? I don't think it should be Microsoft.data, because I think that is way too, it implies a commonality that just isn't there, right? It's a way more specific thing, but it is, the way I understand it, is at least general purpose from the point of view that you can load any data into it, you can look at any data, you can transform it in any way you see fit, and then, over time you probably also have multiple ways you can export this data into some shape, whether it's a CSV file or some, other shape. But I think so the question is, should we first go over the APIs before we decide on the namespace? Because I think otherwise it seems like somewhat backwards. If we don't know what the thing is yet, and we have to decide on a name.
Okay.
Yeah, I just mentioned the namespace to kind of, as an illustration of when I think external customers will see this, like two features as related. Usually we communicate it by, hey, they belong to, maybe not to exactly same namespace, but kind of like, similar area. Operations look similar. I don't know if they, like in ML.NET, there is no API to insert a column, correct? But yet,
iData views are read-only,
Right.
which is another difference between data frames and iData
Yeah.
view.
but new columns can show up. Basically, transformers can insert a new column.
Yes.
Right, you get back a new iData view.
Yep. Correct. And
You had one
we don't think
iData
we can
view.
make this work the same way.
Yeah, how do you model modifications? It's in place, right?
There's options. There's an in-place option, so it's either in place or it's you get a new data frame. Like if you scroll further down, you'll see like an example.
But then you copy the data, correct?
Yes.
Yeah.
So if you say
the other
data frame
thing
dot
too
sort,
is that
the result will be a new data frame. The original data frame is still unsorted, unless you pass in an in-place flag, in which case the original one is now sorted. Does it make sense?
And then the return value is just this.
Yeah.
And is there nothing in the in the what I assume is the expression tree that ultimately gets generated that intelligently says this thing is last used, so we can make it in place even though the user didn't say in place?
No, there's nothing. There's none of that logic because. Yeah, there's none of that logic because in a notebook, presumably when, like at least the examples that I've seen, you always want to copy in all these places. So you did something and you don't like it, you can just do like up arrow and you get what the previous state that you were in. If you're now in place, then it's all fine. Because it's more exploration style. You don't know if that's the end product you want.
Right.
Somebody on the call had a comment. No?
I was going to go back to Christoph's answer or ask question about if we can make these operations look like ML.NET operations. In my opinion on that is like the ML.NET pipeline API is super hard to use, and so I don't think we would want to make that more prevalent.
Yeah, I think the question then becomes more like ignoring the APIs for a moment, but is the idea that DataFrame is not used at all inside of ML.NET, or is the idea that there will be something in it that will leverage that API?
There's at the moment they're completely separated. The way I understand it is you take the data that you want. You take your CSV file, your source, and you do all the exploration you want. So you see if this column is actually correlated to the other one or not. Do all the operations you want, like add columns, do projections and stuff like that. Come up with a set of operations that you like, that you know that this is now your cleaned up data that you want to send to ML.NET, and then you can just use the transforms that you want. You can build that into the ML pipeline. There will be two separate streams.
And then what is your hero scenario? It's basically Spark.NET. Is that the primary consumer then of DataFrame right now?
At the moment, yeah.
Yeah, this is, one of those, I guess concerns I have is that if we don't have multiple consumers, but if you only have one consumer, then you're always running the risk that the thing you're building is very specific to that one scenario, right? Versus when you try to create something that is more, general purpose, you probably need more than one consumer to really make sure that you actually have some general purpose and not something that is, a Spark.NET data frame, right? Versus a Microsoft.data data frame, right? If that makes sense, right? So that makes it harder to...
I see we have two we have two high-level use cases for
Hero
this
would be
this
Spark.
library.
Yeah, good.
One is data exploration, specifically in a notebook, right? In a Jupyter notebook. I want to load up some data and manipulate it, right? Analyze it, chart it, maybe modify it. That's one complete use case. The second major use case that we're seeing is in Spark. There's an operation called a UDF, right? A user-defined function.
Yep.
And the input and output of a type of these UDFs is an in-memory tabular data set, right? Which would be this data frame. And so, like, in there, a user-defined function, right, is like you have all this data coming from Spark, and you want to do operation on a chunk of it. There, you're not like exploring the data like you would be in a notebook, right? There, you're actually like taking that data, manipulating it somehow by either whatever the UDF does to the data, right? If it's adding these two columns or whatever.
But so maybe I'm a bit confused. Do we consider this a PCL feature technology? Is this why we are reviewing it, or like?
I think that was originally the idea, right? Similar to, iDataView was PCLifier, was the phrase we used. So I think this was the same desire. That's why I'm saying, depending on where we land with a number of consumers, that may or may not make sense, right? This is why I think
define PCL. Like in net standard, like is that our hard definition of what PCL means nowadays?
In this context, what when I said is it basically a feature of the notebook, and we just consult kind of to help improve the API, or we see it as a truly general purpose technology.
Yeah,
that's how I would define PCL in this context.
I see it as general purpose. I'm not a proponent of putting this in the system namespace, though.
And I'm not sure that we're going to have something that should be general purpose until we actually sit back, look at things like Python and other languages do, and start supporting combining localized compute kernels properly and optimized so that you don't walk memory again and again and again. Because if we're not doing that, we're always going to be light years behind what other frameworks and languages are doing.
And also I would say, like we may say we messed up and iDataView and the ML pipeline is not it, but I thought that was the idea. So if we think that usability of ML.NET is not great, that it doesn't support random access, would we think about trying to fix ML.NET to support these additional scenarios? Because I can also imagine, ML.NET started as a forward-only lazy. I don't see a reason why for, smaller data sets that fit in memory, various other, scenarios, you would not want different kinds of implementations of some very common abstractions, and then the operations. I completely agree that today that ML.NET pipeline is not super easy to use, but that's another thing. Like, would we consider trying to fix it first if we were working on a truly, BCLE feature?
for ML.NET, the question is really like how much architectural rewiring would be necessary, right? If you have one model that is all about you create new instances and it's lazy, without duplicating the entire API service, it might be very hard to have a model that is in memory and eager, right? Like you almost need different kinds of wiring up pipelines at that point. But I think it's a point well taken, right? We know that when you try to explore ML.NET models and you start with smaller data sets, that the pipeline model is very hard to explore because you have to basically set up the whole thing, debug it one pass, and then change code and rinse and repeat. Versus in other systems that have DataFrame style APIs, you can set breakpoints, you can introspect intermediary results, and things make sense to you, right? And then you can just mess with stuff.
And also, I don't think that iDataView is fundamentally lazy. The ML.NET implementations are lazy, and there are some APIs that kind of, are for the support of lazy scenarios. But you can implement iDataView as an eager API. The forward-only is a separate issue. Random access it doesn't support, but it's not fundamentally lazy. Correct me if I'm wrong, Eric.
I mean, there's the only thing you can do with an iDataView besides get its schema is open a cursor.
Yeah, that's what I'm saying. It's
So, I
not
mean,
random access, but it's also not necessarily lazy.
I mean, if you want to load up all the data into that cursor first, you can. Nobody's saying you can't, right? Like, is IEnumerable lazy?
No.
Can be.
Can be.
Not
In
necessarily.
link, when you chain link operations, it's lazy, but it can be totally eager.
No, same happens with iDataView. iDataView doesn't have to be lazy.
Yeah, exactly.
It depends on top of which data you apply. For example, if you have this array or list that already realized in memory, and you put iDataView on top of that, it's already not lazy. It's already in memory, realized data.
That was my thinking, or how I remembered iDataView. There is one important distinction, which is it's not random access. So that's true. iDataView is not really designed for random
so
access.
the comparison that we did, list and iList, actually there will be a better comparison, list and IEnumerable. So list is our, array is our data frame currently, and IEnumerable, it will be like iDataView. So one is interface, another one is actually implementation of some.
That's actually a really good analogy, right? Because IEnumerable only says I only get a cursor over things, where list gives you a ton more things, right? You can edit it.
Yeah.
So if we think of it that way, iDataView is IEnumerable, and the ML.NET pipeline is link, right? What we're talking about here is implementing list and allow you to add things to it, remove things from it, sort it, etc.
And nothing prevent us in the future to use Arrow DataFrame as the underlying implementation ML.NET also.
I mean, I believe this brings Arrow to ML.NET without ML.NET doing anything, right? Because if you have Apache Arrow data, you can just wrap that in the data frame and then pass that into ML.NET, and it just works.
Yeah, this direction is great. It doesn't. I have literally no concerns here. I have a bit of a concern about the operations working differently, and operations from ML.NET or operations from this feature will basically not working like the operations in ML.NET. You said that the reason it was done this way is that ML.NET is not super easy to use to apply those operations. I agree with that. I wonder whether we kind of gave up on trying to make it easier. And
it's
then
not easy. It's not easy to use, and those operations are 100% lazy operations.
So make it ML.NET eager mode and easier to use is something we need to look at it, but that's something will take a while to reach there.
Yes, maybe.
I mean, how about this? Let's focus on this API here, because I mean, right now we are sorting this API is easier to use and this API is better, but first let's get a handle on what that API is, and then maybe we can later then decide, or should this API be used in other places, and then if not, then let's pick a different name. If yes, then let's pick a different name again.
Cool.
So this is basically, what you have here is the modification part of.
Right, we can skip this unit test. It doesn't show. Okay, hang on. This is inserting and removing columns. So there's an API here that says insert column, remove column. So you can scroll further down.
I actually have a question about in the previous test.
Yeah.
You had insert column, and then you set the name of the column, correct? Go back in one. No, even more. One more.
Like there. These are the indexers.
This was the one with the
column.
column.
Oh yeah. What does it mean you call insert column twice, passing 2?
So that means I'm inserting at position 0 and position 1 in the table, in the data frame itself. So I'm saying the 0th column would be an int column, and the index 1 would be a float.
So I'm looking at lines
201,
212 and 213. They basically both insert at the same location.
Right.
That shifts. That's what it's trying to do.
Hang on. Let me see.
So first you insert big column, then you put repeat name before big column, right?
Right. I mean, I'm throwing the exception,
Yeah,
catching it. I need to know why I'm why I'm throwing.
Something's throwing.
I see. Yeah. I guess because you already have the names.
I wonder if I have big column already.
I think it's because of the bug I logged that said you can't replace columns.
Oh, that's right.
Like-
No, actually, the column names are different, so it may not hit that code.
But here you're trying to put it at index 2.
That's right. This. Yeah, that's right. Correct. So, yeah, ignore those 2 lines. That's a bug. that is now fixed.
So this is supposed to work.
Yes.
What is the intention?
The intention, the intention was I did not want 2 columns with duplicate names in the data frame, because then when I say data frame of column name, if there's 2 column names, I don't know which one to return. So I was throwing.
Got it.
And
The
now
idea
what-
is
and now
right shift,
what
right?
does it do? What does insert
Now
column
it
do?
means if you're replacing, so the bug was if I replaced a column with another column of the same name, I was preventing it, but I should, because that means I'm replacing one column with another column of the same name, so it doesn't matter.
I see. But you're passing in an index too, right? Like what happens if you pass in a different index?
That would throw, because that means you're having duplicate column names.
Okay.
Yeah.
But
So
why
insert
is
is
it-
replace.
Yeah,
in
but
this
that's
scenario?
There is a set column. Yes. That there is a replace. Like, okay. Whether you have an insert or a replace, if there is a duplicate column name, it throws. Instead, if you replace like column A with column A again, it's fine.
But the verb here is insert, not replace.
Yes, because they're 2 different things. Like you can insert a column anywhere you want,
Yes.
and that's okay. Set is the actual replace. Insert is not the
But
replace.
basically, insert. I think so. To me, logically, if I insert a column
Yes.
with a name that already exists,
Yes.
the index shouldn't matter. It should always throw.
Yes.
Yeah.
That's what it does.
And so set is the only one where it's like if I replace the exact column with then that
Right.
should work.
Yes.
Okay, that makes sense. All right.
Okay. Scroll down.
Gee.
Okay, these are the binary ops. Scroll a little further down.
I have a question on the binary ops.
Yes.
So
I
if you
Any
have
questions?
if you have a data frame that's like, let's say 100 megabytes,
Yes.
each one of these is going to walk that 100 megabytes separately, right? So when you do add, it's going to walk the 100 megabytes doing the add operation, and then
Yes.
next when you do divide, it's going to rewalk that 100 megabytes
Yes.
again.
Yes.
Do we have any plans on providing an API that allows you to walk the memory once?
So like chaining operations.
Basically, because otherwise you're the slowest possible thing you can do on a computer outside of like network access
Right.
is memory access.
Yes.
And so you're changing something that could be walking 100 megabytes once into walking, 2 gigabytes by
Right.
doing 20 operations.
Okay. So we don't have an API that does that because there's 2 reasons. The first one is like on a notebook, if you say dataframe.add something, and then on the next cell, if you say dataframe.add.divide something, because there's no way for me to differentiate which one you did, because I don't have I'm not building the set of operations that you're doing. So like I don't know that you're doing an add followed by a divide, so I can combine those 2 together.
So it sounds like you were saying the caller might need to observe the intermediate state.
Right, we don't have that yet.
Well, I think that
There is an
again,
API that gets you the buffer directly, though.
True.
Here's
Right,
the
but-
buffer. You can go do add, multiply on each step. all the
Yeah,
way
but
down.
that requires people to go and write their own, basically compute kernels that do add and divide combined. And so you've got an explosive number of expression trees that become infinite, rather than having a system that understands them inherently and combines them themselves, which is like what Python knows how to do.
Right. I'll just add one caveat, which is there's function application, which would go to each element and do whatever function you want. It's limited in that you can only you're given in a T and you can return a T, so you cannot convert from int to a float. So it's what you want exists as long as you're in the same data type.
And you're willing to write the function yourself.
Right.
Rather than using the existing built-in
Yes.
kernels that might be hyper-optimized already.
Yes.
Why do you have to be in the same data type?
Because going from an int to a float in place would mean I have to change the backing store itself, the memory itself.
So the backing, instead of the individual, sorry, let me back up. So the actual backing store has each of these values in a, let's just say a matrix or an array, as opposed to each individual value being boxed.
Yes.
Correct? But when you call the indexer, they get boxed at that point.
Only if you're casted as a base column.
Yes. Not on the
If you're
concrete
casted
side.
as a column of
Got
T, it doesn't get boxed.
Okay.
Okay, so you can scroll further down then.
Going back to the compute kernel stuff, another thing in the Apache Arrow project is exactly there's this thing called Gandiva, which is like basically like compute kernels built into C++ on top of Apache Arrow data, right? And so a plan here is, since we're building on top of Apache Arrow, in the future we should be able to take advantage of any new capabilities that come to the Apache Arrow realm, space, whatever you want to say. So that way, if you did want to make hyper optimized like expressions, if we would just translate that into Gandiva and tell that C++ kernel, go do whatever you need to do. Here's the data.
Okay.
Right.
That makes sense?
Yeah. It still seems like there's a gap there for like ML or general purpose tensors or stuff, because it's going to apply everywhere. But maybe that's a separate discussion.
Right. We could add the query planning stuff into the data frame. It doesn't exist now. Okay, we can scroll further down.
I don't know. The thing is, I don't know if that's what the business we want to be in, though.
Right.
Like, especially to duplicate the effort of what the rest of the Arrow project is doing. I think we want to piggyback on top of what they're doing.
Okay, scroll up just a second. Okay, hang on. So right, so this is still doing binary ops, but this is with operators instead of the APIs itself. So you can scroll further down. Sorry, Mo.
Those were good ones, though, actually, if you go back to that test.
Okay.
Right? Like, DF1 of, I'm on 317, right? Like, doing the equals on two columns compares each value in the column and then gives you back another column full of booleans.
Yes.
That is true, false, whether those values equaled or not.
Yeah, that one is the only one where I'm not sure that's such a good idea. I mean, generally speaking, when you do plus and minus, I think it's fine if the return type is within the same domain. That kind of makes sense. But for equality comparisons, I think it will be... I mean, it's not impossible to do reference equality checks, right? But just either doing object.reference equals or doing is null or is brace to do the typical null check thing. But I think people will find that confusing.
Isn't that how vector operations work in .NET?
No, we didn't do operators. We did name methods, but for other reasons, because we couldn't overload the way we wanted to. But yeah,
I wouldn't make operator equal return anything other than bool.
But that's what I'm saying. Isn't that how vectorized operations work?
No.
You have some operations that let you compare values in vectors.
yes, but the problem is there's too many different ways you can do that, and so we ended up doing methods anyway. Yeah. There's no operator for that.
Oh, you just commenting on the operator.
Yeah.
Yes.
I'm saying
okay.
But
not having the functionality.
No, the scenario makes sense, but
Yeah.
I think if you called, dot element equals or something, that's fine.
Yeah,
That's it.
because
don't be cute with
I buy it. Okay.
basically how the vector works is you compare and you get back a vector of the same type where each element is either 0 or some value for true, and then you extract a mask.
didn't get the fact that the comment was about the usage
Yes.
of operator. I agree, because you would immediately want to use this in an if statement.
Yes.
And say if this equals this other thing, and then
The answer is not quite.
So if we take equals away, like how far does that cascade, right? Obviously not equals goes with it.
Right.
What about greater than equals? What about less than equal?
So the inequality operators are inequality operators. They return true and false. They don't return. They are not vector operators.
Well, you can still have equals because all platforms also provide a version that says are all equal or are none equal.
Right.
So you could have the equals basically do a are all elements between these two equal,
right.
which
But
is what most people would expect the default to be in
equal, not equal, less than equal, etc. All return a Boolean.
Yeah.
They don't return any sort of array or list or column. They return a Boolean. That is what those operators do. It is, you can use it in an if. It is a single 1-bit value.
So what we would
Have you ever seen what people do with Python?
Have you ever seen what people do with C?
Doesn't
No, I'm just
Sharp
saying,
actually
like, I'm
restrict
just
the
saying, like,
return
the
rule?
expressiveness and like the thing you can get done in one line of code that actually semi makes sense. It's super powerful, right? Like,
sure, but our general guideline is don't be cute with operator overloads. The Boolean operators return a Boolean. The inequality operators are all Boolean operators. It's just don't be cute with operators. That's .NET.
If we had, so what would the suggestion be then? Just a static method that returns a new column that is the equals mask between A and B?
Yeah.
Then
You
that
do
would,
anything you want with a name method.
I think
you
that
just
should
can't use the
cascade
operators.
to all operators. Like, I don't think we should even to plus and minus and multiply. Like, I don't think we should do any operators then.
Because plus, the general rule for plus is a thing plus a thing returns a thing in the same domain.
Yeah.
So a column plus a column returns a column. That makes sense. It's that less than is a true or false answer, not a.
What
not
about a
positional
column plus 1?
That doesn't
What
make
does
any
that reach?
sense.
It does make sense though, right? It multiplies it.
You can make it.
What's
make
the
sense.
word in Pandas in NumPy? It broadcasts. It broadcasts the 1 to all things
Right.
in
Why
space,
doesn't it append
right?
the one to the column?
Yeah, because if it was a string, it would concat. So again, it's being clever with operators. If everyone wants it and everyone thinks
That's what I'm saying. Like,
follows-
we should remove all operators. Then.
that's what even the compiler
If the
does.
rule is don't be clever with operators, then all of these things are being clever.
We already do things like multiply vector by scalar in numerics because mathematically they are well-defined
Right.
operators.
So I guess, if it has a well-defined thing and everybody believes that a column plus a scalar is make a column that is the same height as the other one from that scalar and add it, then fine. But like equal you would expect to see in an if statement. And if equal does something that can't be used in an if statement, that means you're being clever with your operators, and that's not .NET.
So the one thing that I remember when we did the SIMD stuff, we did review it with Anders at some point, and I think Anders used the phrase of like, it wasn't so much about operators, it was specifically about equality. Like, equality is hard, and people have a very, very pre-canned understanding of what they think double equals does, and I think returning anything but Boolean will fuck with that. At the same time, though, you expect people to be able to overload equals, not to mess with the return type, but to just change the way you do equality, whether you could look at contents or not at contents, right? And I think with plus and minus, people kind of have an intuitive understanding already that the types may change, right? If you multiply an int with a float, you don't get back an int, you get back a float, right?
Yeah.
So people understand that for arithmetic, the return types may differ, and they don't tend to use that in if checks, right? Versus every time I use SQL Boolean and turns out they overload operator true and operator false, it does fundamentally mess with your intuition of what these things do. And that's why I think A plus B in columns, that seems reasonable to me, because you can argue whether it does this or it does that, but I think as long as there's a sane definition of what it does, I think it still is within what people would understand.
I think there's more to it. I think operators work better in domains when there's an expectation that operators would work. So in the domain of numbers, that plus, if something claims to be a number, like an int, that it's gonna support plus, minus, multiply, and this and that and everything.
Right.
Here I also worry Like, how will people know that column has a plus operator that takes an int? It's really nice, it looks very nice once it's written, but operators are not, they don't show up in IntelliSense.
That's right.
And it's a bit surprising that, I can add one to a column. Second thing, I think it's a bit unfortunate here is that when operators work everywhere, it kind of looks nice, like math. You can add two things. But here it's like a mixture of methods that are not really named as methods, like for example, column that takes an I. It doesn't follow our naming conventions for, frankly, method names. And then you can plus it. It's cute, but you already have a method call. Like the column passing an I already doesn't look like math, really. So the plus is kind of...
Right, I mean, you could change that to df1 of like column name plus one. Nobody would have to do
this
the
code
dot column
isn't
of one.
this isn't sample code, right? This isn't like how we would tell people to make
So I think
code,
the one
It's just
thing
intent.
you brought up, which I buy, it's the same thing we saw with things like object initializers, right? Like if you look at how people discovered that in our JSON APIs, they usually didn't, right? They either had an expectation it's there or it's not.
Yeah.
But once you know it's there, it makes your code really nice to read, right? So I think it's generally true that for every operator, we would have a method that does the same thing. So if you just discover IntelliSense, you see those methods, and then that's the way you would do it. And at some point, you see sampler code where you see, oh my god, they do super compact notation, it reads super nice. And so I think in that sense, I don't think we need to take something away from people because they don't expect it. But at the same time, I think when we give something to people, it has to be self-consistent, right? And I think within DataFrame, like to what Eric said, in the Python community, people do that, and it is part of the reason why DataFrame is successful there, because it is fairly compact, and because you can do relatively complicated things in what looks intuitive. You can look at 4 lines of code, you can reason about what it does, versus if you look at vector multiplication in C, where you don't have operators, it's very hard for you to visualize what it does. You have to literally read the text and then basically draw the diagram yourself.
I agree if we could kind of make it all work and looks nice. I didn't know that there is actually a mathematical notation to access the column.
Right.
What I was commenting on, right now it seems like, there is a plus, but the rest of my code looks very verbose and not mathy.
Yes.
And I would say then maybe it's not worth it because of the reason. If there's end-to-end story and it all looks like math in the end, then great.
Going back to like equality though, like it depends on what domain people are coming from.
Yeah.
If they're coming from Python and they're used to this concept of equality, they don't care that .NET equality is different.
No, but I think that's a jump that is not legal for the reason that you can't take a Python developer and drop him into .NET and expect him to be successful regardless, because it's a completely different thing. Everything is
But
different.
for this particular domain,
if you're a Python developer who's already steeped in this and has already written Python code to do data analysis like this, why not just remain in Python?
Yeah.
Like what value add are we actually giving to people?
To me, so
Because Python is super slow.
Well, there might be a reason why I want to migrate away from Python, but I think to me it's not important that feature X in .NET is the same as feature X in Python, because that's not how the world works. Right? You can't just work. You don't just move to .NET for this one feature. You now have to absorb the rest of .NET. You have to access files. You have to deal with the compiler, with the IDE. There's a whole different ecosystem. And so once you're in that ecosystem, it is super important that things are self-consistent. And so that's why I think equality is the thing you really can't fuck with, because it is already very complicated in .NET. We have value types, we have reference types, we have different semantics. And so if you now also blend in the fact that, in this one feature, we also completely redesign what the expectations are for equality, I think that would be fairly bad.
Yeah.
That's why I think for equals, I really don't think you get to return anything but true.
We would be making a feature for Python developers and not for .NET developers.
Right.
But it comes back to my original question: why would Python developers leave Python?
So in our design guidelines, we say equal is the same as I equatable, and the inequality operators are the same as I comparable. That means that they are Boolean operations.
Right, no, sure, I get all that. The only pushback I have is, for now, you guys have only been doing column plus one, and then if you chain operations together, then you could have operators everywhere, except where you have, when you want to do equals, you have to say dot equals, and then you have, again, just operators. It doesn't look that
Even
good.
dot equals isn't going to work.
Because dot equals would presumably
That one you
be
definitely don't need to change
the
the return.
thing that returns a Boolean that is is this the same as that one? If you want pairwise, that would be pairwise equals, or
Something
something.
like that, yeah.
Like you need something to indicate you're doing something other than what.
So
the
don't get me wrong,
operator-
I hear what you're saying, and I
Right.
think this goes back to what Eric said earlier. Should we remove all operators? So to me, this is kind of like the throwing out the baby with the bathwater. But like I think the one thing you need to think about is how often do you do plus minus, concat multiplication versus equality. I would assert you probably don't compare columns that often compared to other modifications you make.
Okay.
So giving up the compact syntax just because you really don't want to do it for equality, might be a bit much.
I would assert that
Here's the
statement
thing
is
you do.
incorrect.
Here's the thing you do is like give me all the values, give me all the things that are greater than 500, right? I want all the big rows.
And that happens
Right.
all the time when you want to filter. Yeah, like what he says.
So doing a vector-wise comparison and getting back the equality mask is the most common way to do things like branchless ternary select with vectorized code.
So for that scenario, why not have like a filter method that takes in a predicate, and rather than returning a true-false column, it just returns the values themselves based on the true-false results.
It is, but the way you write it is like data frame of, and then you say data frame of column greater than 500.
I see.
The predicate is inside the indexer.
Yeah,
Right,
I mean,
that's what feels natural in a notebook. Does that kind of make sense?
So you pass the lambda to the index, is that what you're saying?
I'm saying like you want to return all those rows where the values in this column are greater than 500. So you say data frame of column greater than 500.
So like by off you mean brackets?
Yeah,
right?
by square
So
brackets.
basically you pass the lambda expression, if you will, to the
indexer itself.
Yeah.
But if that's reducing the
It is
number of rows you get back, that's a filter operation and not a return a column that contains the answer of the inequality.
Yeah.
Like these are again a different operation that you could say this is what I want less than to do, and like it. In fact, the actual rule that I thought paraphrasing is don't be cute with operators is actually do not be cute with operators. So good job, Christoph.
So
So definitely all comparison operators go away. That's what we're saying.
All of
They go
the
where?
equalities and inequalities are single Boolean operations.
what's wrong with having a method which is literally like .where greater than or something like that?
That's fine.
Is it
That's
just
a
not
method then.
discoverable?
It's a method.
There is
the
no
method?
IntelliSense on the notebook yet. But I was going more for, because it's all weakly typed, I was going more for as less typing as people can. Because if there's no IntelliSense, nobody's going to we'll have to keep looking at the documentation, come back and keep writing stuff right.
Is the idea that people are actually going to be writing C# in the notebooks, or are they going to be writing some other language that can be translated into calls to this?
C#.
Or potentially F#.
Yeah, .NET.
Yeah.
So we would expect them to be. So would we expect them to be writing things that are canonical C# style code? Or would we be expecting them to write things that are terse in order to be used inside of a notebook? What's the scenario we're in?
I would expect the second one, just because if it's mostly data scientists using the notebook, I don't know how C# they would be.
So
But
does
then-
that mean that we needed language other than C# for them to work with?
No, it's still C#. Like it's C#.
If it's
Really?
C#,
Like
then
that's-
they're gonna be calling all the framework APIs. Therefore, probably they would want IntelliSense, and therefore they should be okay with methods because we have all over the place lots of methods in .NET framework.
So one of the problems with
We'll bring
methods is overload
IntelliSense there.
resolution, or is not overload resolution. PEMDAS, expression ordering. If you're using methods for add, subtract, multiply, divide, you have to be very explicit and very careful about how you order those expressions.
Yeah.
You don't get the compiler just saying, oh, I know multiply comes first, so I'm going to do that even if it's over here in your expression tree.
Yeah, I was not saying that C# is the best language for these scenarios. I was just saying that
Well, I mean, that's
if they're
true
gonna
for
be
any of
writing
them.
C# here, it's gonna be more than just operators on those tables, and therefore they sooner or later gonna end up in a .NET world which is full of functions that have names and they are long, and IntelliSense would use.
I mean,
Eric, you had a comment?
Back about IntelliSense, we'll bring IntelliSense to the notebook experience. Like that's not a reason not to do something.
Yeah, I would agree with that. I think though the one thing that I would say is that there's a reason why we have operator overloads, right? And that I don't think we can talk away the fact that when you call a method, both syntactically and in terms of number of characters on the screen, it is fundamentally harder to read, right? Like that's I think the thing. If you want to like say, let's get a Python punter style experience into .NET, that is the thing we have to think about how this will feel natural. Even if you're a C# developer, like how do you get the same benefits of a compact notation where you can do fairly complicated, data translations in a way that feels, both intuitive, is easy to read, and also easy to express.
But I think that everybody in the room is okay with adding operators for things that feel naturally like operators on numbers.
Well,
correct?
The remaining thing there is then if there is a place where people want and need to be able to do equalities which return a mask, and C# doesn't have support for that today, then is that something that we needed to talk with the C# LDM team about to see if they can add new operators for that?
Sure.
There's already a proposal for a new power operator. So maybe we need something that says, here's equality in comparison that return a mask.
What I've heard multiple times during this session is that this is not intended for typical .NET developers. This is intended for data scientists who aren't otherwise steeped in the .NET world. And that also comes back to the point that we spent a while, beating earlier, which is, does this belong in core effects if that's the target audience? And I would say the answer is no, if that's the target audience.
I mean, I definitely don't agree that this isn't intended for .NET developers. This is totally intended for .NET developers. But it's intended for .NET developers who want to do data things, right? They don't want to have to go to Python just because, like, there's no data things in .NET, right? Like, I need to do big data. Well, there's no Spark.NET, so now I have to go learn Python or Scala, right?
So it's
there's no machine
intended
learning.
for .NET developers.
It's totally, in my opinion, this is totally intended.
No. But let's step back. Is it for .NET developer with ML background or data background, or not without data background? Those are the different audience.
I think you have to have some data / math /
Also, one of the things
science.
usually happen a lot, and this is why a lot of people standardize on Python Word. There is tons of code and from papers that are available in Python, and people try to copy or move this code back and use them. So I expect also in people that use .NET will look at Python code because there is a lot of Python code and try to convert it to C#. And the easy we can do, we can show them how to migrate. It will be easier for people to implement their algorithm or using .NET.
Well, and I don't think that, even though this might be primarily targeted towards people who have some ML background and stuff, one of the reasons people like Python and they're able to do it is they might be trying to add some minimal ML to their app or something like that. And Python is very easy. You just open a command line, you start typing code like you would math or anything else you already know, and you can get results. Because it's familiar to people even if they don't have that data or ML background. They just type math and they get math back out.
Right.
And that's basically all this is data frames, vectors, tensors. They're all just well-defined mathematical types with well-defined operations. So if you understand math, you can type math and you get math back.
Yeah.
Right. So, like, I have no objection to the asterisk plus hyphen minus
things that normally wouldn't
slash
return bool
and percent operators. Those are fine. It's the equal, less than equal, less than, etc. Those are we have a .NET developer has a very strong understanding that those return a Boolean, not a vector of Boolean, not a tensor of Boolean. Like, they return a Boolean.
Yeah, and
the fact that vector never overrode less than to return something other than Boolean, like, is
so that's the extent of like, I'm only arguing about the ones that do or could have an equal in them. I guess plus equal could have
comparison.
Means a different thing. So the comparison equal as opposed to assignment equal, like the inequality operators and the equality operator, which is a special case of an inequality operator, are a single Boolean, and we have that. It's actually mostly implicit in the guidelines, but the two specific things we have are like the I comparable translates to the classic inequality, and I equatable translates into equal, equal, and not equal.
Yeah.
So we've said those are single Boolean, and that is the defined behavior we have in .NET. And the whole point of API review and framework design guidelines is .NET feels like .NET, and not this thing that came out of inspired by Python feels like Python. It needs to feel like .NET. That is the number one rule in .NET. We are .NET.
So don't get me wrong. Like I completely agree with what you just said. At the same time, though, like I think the goal is not to take a Python concept and port it to .NET, right? I think the goal is to say there is something that is really popular and successful in the Python world for a particular set of characteristics. And so the question is, if we were to build something that has similar characteristic in .NET, what would be the .NET way to do that, right? And I think we just discovered that for operators it is harder because people, like the way strongly typed systems like C# or Java work is that there is an expectation for what certain operators do, right? At the same time, though, I think there is a desire to say, can we find a way to do these things in a compact fashion? I don't know what they would look like, but for example, one thing I could see doing is instead of saying we have these operators on the column type or the data frame type, which is the thing that people will pass in and out of methods, and thus you probably want to do null checks against, is different from saying you have a method that takes a lambda. The lambda has some funky arguments, some types, and those have to have certain operators defined for them for you to express what that condition looks like, right? And for those things, maybe we don't care that we have a double equals because those are not the things you actually pass in and out of methods. But I think the question is, can we get a compact notation to do column-based transforms and not create a world where people, when they're through argument validation, are surprised that double equals doesn't return a boolean anymore, right? So I think to me it's more like, what would the API shape look like to get this into. Maybe there's also like, I don't know, maybe missing C# features or whatever, but I think we should think about that.
Yeah, I think we are missing C# features here for doing mathy stuff.
But I also wouldn't like use the existing features and butcher them into submission, right? That's also probably not a very efficient way to doing it.
So equals is a hard no? Okay.
Yes.
Okay.
As are the inequality operator.
Got it. Yeah.
Where does it go? Where are we proposing they go?
So our rule is if you have an operator, you have to have a named method because not all languages can invoke the operators. And we're saying get rid of your operator overloads, only have your named method.
Yeah.
Yeah, but you're okay with the name method equals returning a column instead of a bool?
I think it needs to be something like equals mask because one, you already have a method named equals, and anyone who has IEquatable or IComparable or any other .NET background will by default assume greater than returns a bool. So you need something like greater than mask.
What if it does not implement IEquatable though?
I still think the default assumption is that it does.
Yeah. If your method name dot equals.
Yes, you're reviewing a bunch of code. It has var all over the place. You have no idea you're working with this type. You see var something equal thing dot equals.
Yeah. Okay.
Your brain as a .NET developer knows what that var is now.
I mean, look at vector of t.
What if there's static functions that take two columns, or potentially a column and a scalar?
I just agree with Tanner's suggestion of mask. You just want mask equals or equals mask or whatever. It suggests that it's returning a piecewise vector of data as opposed to a single piece of.
So is this concern only for equals? It's not for like greater than, less than.
No,
it's any comparison.
All comparisons.
Comparisons that result in bools specifically.
I see. Like I get like we as differentiating the equals, like equals master, etc. But greater than and less than are already large enough, and I don't think that common that people have this preconceived notion.
It's IComparable, so anything that does sorting.
I think if I read var b equal a dot greater than c, I haven't used that one yet. I believe that variable is a boolean, not a vector of boolean.
Because that's honestly what confused me here.
And not variables.
It easily follows. One follows the other, right? It's like equals equals. If you say no, then greater than equals has to say no, and then therefore greater than has to be no, right? Like you can't. They all.
You want the word mask
together.
in them, and that maybe here there's there's room for suggesting to the language design that we need a tilde greater than equal, which is pairwise instead of. And then now it's a new operator and nobody has any preconceived notions on it.
To be clear though, that's not what we did for vector of t. Vector of t, we have equals that returns a vector. We have equals all equals any We have greater than that returns a vector. We have greater
Exactly.
than or greater than any.
Vector of t in particular, we said was very special, and it was documented to be a hardware.
I don't see a reason
But
why
it's
the
a
same
special,
argument
so-
doesn't apply
yeah,
here.
exactly.
You could just say this is a special type,
Fair
and,
enough.
and
I
then
mean-
we just say this is because I think for the argument we just earlier, they're static methods, right? So
Yeah.
that the way you invoke them is so different already that
I guess, yeah, if
you don't
it's,
really
it's
have colliding
purely
things.
static methods, then you don't get the, like, things stand out a little more when you're
Yeah.
invoking a static
And
method.
if
If it's
they
an
need
extension
to-
method or an instance method, then I think, especially in a world where people like writing var,
Yeah.
like, you can't really understand what the flow of what you're getting is, and worse, you have an expectation that is wrong.
Right.
Like when var leaves you ambiguous, that's okay. When you have concretely decided the wrong answer, now that's when you get confused when reading the rest of the code.
I guess to be fair, that's also what we gave up in vector of t, right? When you actually write vectorized code, like your intuition is no longer serving you in any way. Like
We also, like, another argument, we also don't tend to put operators on non-sealed types. Because you could override a change of behavior and the operator is a static function.
Well, but the operator is just supposed to defer to the name alternative. That's our guideline of how to.
Yeah.
and you
correctly
make that
override-
virtual, so you do
overload
whatever you
operators.
want.
Well, that means those have to be virtual, yeah.
Yeah.
But I mean,
We should scroll.
so should we look at the APIs at all, or should we just go with the samples?
Right. Well, so one of the things I've noticed so far is there's a type called base column.
Yeah.
We don't
Yeah.
use the word base. So
Okay.
So let's do the following. Let's
Yeah,
look at the
let's
APIs
propose
to look at the core types maybe, and then
we have avoid using.
Yeah.
It says avoid suffix base, but
Yeah.
prefix base would also apply.
Yeah.
If it's a usable type by itself, then it should just be data column or something, and then
Right.
you've got specialized types beyond that. That's fine, but like we call it collection of T, we don't call it base collection, even though it's mostly only ever used as a base type of other collections.
I think the only case where we've made an exception to that is base as the suffix for the hardware intrinsics, like ARM6,
Yeah.
ARM base, because it's the base ISA.
And
We didn't. I don't think we ever came up with a better name for that.
But that wasn't that it was a base class, that was that it was representing a thing that in the spec is itself called base, right?
ASP.NET has types that has abstract base classes that have base in the name.
Right.
Yeah.
I mean, there is some precedent for it.
There is.
There's a proposal lower near to rename it, and I think that rename is fine,
Yeah.
right? Like data frame column,
It's
Yep.
it follows like an If we call the major type data frame,
yeah.
which I don't know if we're 100% agreed on yet or either.
it just-
Whatever that thing is, column probably makes sense for this base class.
So should we start with like a concrete type? What type should we start with to discuss?
Data
Base
frame.
or data frame?
Yeah.
So the
Data
guideline
frame
is
and then base column are the two most
the
important
main
types. of this.
avoid naming base classes with a base suffix if the class is intended for use.
But
in
it's a
public
prefix, so
APIs.
it's okay.
Yes. Like I said.
Touche.
It probably also shouldn't. Yes, it implicitly includes prefixing. Well, because prefixing we don't like because it puts all your stuff in weird places and it tells
So
us.
you want to go down to data frame.
Data frame.
Yeah, let's go to data frame. Should we start with the name of that? Are there better names than data frame for this?
Oh man.
Like,
I mean,
No,
like
Probably, but
names are always hard, right? Like it feels like after we understand what functionality it has, we can have an opinion on it. But at least me, who was on vacation the whole time this was proposed, I see this as
Can we collapse the comments?
should we call this thing a car? I don't know. What's it do?
Okay.
Yeah.
well, we
So
just spent an hour and a half
yes,
talking
I
about
got
what
it.
this thing
Is-
is, right?
Indeed.
Like,
Is
I
the
think
name?
we should have a good.
We're just gonna unresolve this.
I was thinking, like, if the name data frame
Oh,
is
let me do
familiar
it.
to somebody already, in this world, then
Yeah.
whatever.
That's why I
Yeah,
chose data.
because
frame.
we do tend to say, like, if somebody who already has domain specific knowledge would see that type name and say, oh, I kind of know what it does, then
Yeah.
it's a decent type name.
As long as somebody who doesn't have the domain knowledge wouldn't believe it means something it isn't. So
Sure.
if it's overly generic, then we should.
Well, maybe,
Specialize
at
it,
that
but if
point,
we
maybe we
feel
could put it
it's-
into a different namespace.
Right. If we feel that it's appropriately generic, then yeah.
So this
And
is a naive question. Like, what does frame mean? Like, we have data frame. What can you like break that down? Like, what is it supposed to mean?
I think frame means
Like a
like,
picture,
view
like a picture frame.
for the data.
Square.
It's like a stack frame. It's like a view of that like data. You could call it like a data view, which would kind of mean the same thing as a data frame.
Fortunately, we have an interface iData view.
Right.
So the problem is the type names data table, data view already taken.
Yeah.
And data set.
And data set. So, and fortunately though, the other ecosystems use the name frame, so which we haven't used in .NET yet. So
Yeah.
So
it seems
frame
that-
is coming
Well,
from.
so a direct issue of this is Spark.NET has the concept called a data frame,
Right.
and it's like a distributed data frame, right? Like it can represent data that's, some of it's on this machine, some of it's on that machine, some of it's over here, but you're running and it represents all of the data across all of this. And since we actually want to use this type in the context of Spark.NET in those UDFs that I talked about earlier, the names directly collide,
Yeah.
right? They both want to be called data frame, where this one represents an in-memory frame of data, where the other one represents like a pointer to data somewhere in the Spark ecosystem.
Yeah, I suggest let's ignore this for a second because this goes back to what Krista said earlier about let's make one feature or one technology with multiple features rather than competing technologies. But let's just take, I don't know, I don't see enough reason right now to have a different name than data frame. I think once we talk about how this embeds in other things, maybe we need to have a different conversation about that. But
I mean, if a primary use
Conceptually-
case of this type is to work with an existing library that already has a type of this name,
Yeah, which
then
shouldn't have
the
that.
guideline is try really, 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 really hard to come up with a
Yeah.
different name here because we don't like types that differ only by namespace
To
when
be
they're
fair, though,
expected to be used together.
Spark.NET is also, is that stable yet? Is it capable?
No,
So we can
It's not
rename the
stable
other name as well, right?
Sure.
no, it
No.
kind of can't because
It's an
it's
attack.
called a data frame in all the rest of Spark.
Yeah.
And so for C# to call it a data frame when Python, Scala, R all call it a data frame, they're not going to rename it.
Yep.
So again, we'll put a pin in that, and
Sure.
maybe it needs a better name, but
Okay.
Okay.
Take it. Yeah. I take it record batch is already a defined type outside of this because I
That's
didn't see
an
that.
arrow thing. Yeah.
Okay.
Yeah, that's one thing that needs to change about this API tool is like types that aren't in this API review, that aren't in like net standard,
Yeah.
should kind of be fully qualified so that way you know what they're talking about. iData view and record batch is exactly the problem.
Okay.
Yeah. So I resolved all comments for now, so they're collapsed, so we can look at the APIs. But we want to look at some of the comments.
okay. So why is columns returning an iList? Or rather, sorry, let me change my stress. Why is it returning an iList?
There was a comment that says we could change it. That was before the notebook had custom formatting support. Now that it does, we don't have to do the iList.
Okay, because our general guideline is if you always return the same type, someone is going to depend on that and they're going to cast it.
Yeah.
And only return the interface from a property or a method if you actually return multiple different things from that interface, so you will break someone if you want.
So, for example, in system link, we have a .toList extension method, and it returns a list of T, not an iList of T.
Okay.
So it's-
Here, we can return a read-only list, for
Right.
instance.
So it's
Yeah, either that or what I suggested is like have your own type because then you can extend it. Right? If you
Yeah.
ever want to have an indexer by name, for example, then
yeah, essentially it gets weird because it's parameters should take the least specific type they need, and return type should be the most specific type because someone's going to depend on it.
Which was also another comment for the constructor here. Like
Yeah.
maybe the constructor takes an IEnumerable,
Right.
because it's the most generic thing
Yeah.
you can take.
Okay.
so my
So
my other
So-
question is what do you have column count and columns? Seems to be redundant. Columns.count hopefully returns the same number.
Allocating the whole list
If you
to get
already
your columns back. I guess once it's read-only, you can return the
Yeah.
same cached view until
Right.
it changes. But understanding the column count without asking what are actually all of the columns does seem valuable.
Eric, were you going to say something? I think it was Eric.
yeah, I was gonna say on that old comment, like what's the recommendation here? Well, first let's back one more thing up. Is somebody taking notes?
Yeah.
Yes, I am.
And if not, maybe we should start, I guess. But
We
and
have no
then
takers.
so the comment was column should be iRead-only list
The
No, it
return
should
type.
be
or
Uh,
list of
whatever columns is returning, like whatever it actually returns. So call columns, then call get type. That is what it should return.
It's returning a list, so it should be a list itself.
Yeah,
Well,
or it should be
it should
read-only
A
list.
read-only list.
Or,
Okay, yeah.
or your own custom column collection type,
but
if you
it's-
want to put special indexers or
If,
whatever. on
if it was get set, which would be a violation of a different rule, then the iList would make sense. But since you are only producing data and it's a collection, you should be
Yeah.
the most specific collection type you can.
Okay.
Yeah,
And in
Or-
this
or
case,
define
we're
your own.
recommending our own collection type.
possibly.
If you think that you would need to extend it in a weird way in the future, sure.
So you could do dot columns, index, index, int index, string index, and so on, as opposed to having like a dot column method on the data frame. It just feels a bit more natural
Yeah.
for .NET developers.
So the other problem that I see with this API is that it's a list of strings, right? Which is the name of the columns.
Right, because really it should be column names. Because columns should
Right.
return the columns.
Yeah.
Right.
And I kind of think like the whole schema-ness thing, like what are the names of the columns, what are the, the types, etc. I think that should just be a separate property.
Well, if you had your
And
own
then,
custom column view and then a column type, you could expose everything that way and extend it in the future as needed.
Yeah.
so you mean if this was a list of data frame column, whatever kind of list, like data frame column list or whatever,
Yeah.
and then on those things we have name and type as properties.
Right. On the actual column, you could have name, type, value, anything else you wanted to extend it with in the future, as you saw necessary.
Right. You don't need to split out schema from data.
Right.
You can keep it in one class. Okay. And then remove column count.
Unless it's important to a column that it not have a name, so it can be reused somewhere else without its with a different name. Like, if you don't have that use case, then having the column understand what name it has is good.
Does a column have a collection or have a concept of a parent?
No.
Okay, so it's literally just its own freestanding thing. Okay.
Yes.
And we need to allow it to be its own freestanding thing as well, or at least because in Spark, there's the case where you just want to pass in what in Pandas they call a series,
Okay,
which is just one collection of data, right?
that seems fine.
So in general,
And so in this case, it's kind of weird, right? Because we're like, well, here's a column. And it's like, well, is that weird? Like if you just want to pass these things around as kind of like an array would be, to call it a column, not parented by a frame.
It doesn't sound weird if you have scenarios for it to
Right.
just exist on its own.
I meant the name, like using that type column.
I mean, assuming it's... If this is called data frame and that's called data frame column, then that seems fine. I don't...
Okay.
These days, I tend to make tree-like types like that not go back up because it gives you a lot more flexibility. If it's not important that a column know about its data frame, then don't tell it. Because especially what happens after you get one and if you remove it from the data frame, like what universe are you in now? Just don't add up unless you need it.
can you add a column to a data frame which has a row count that's different from the rest of the columns in that data frame?
It throws.
So column needs to have the concept of how many rows I have as well.
It has a length, yeah.
I see.
Which is usually the name of the returning property that is what is one bigger than the biggest number you can put in the indexer.
Yeah,
so it seems fine.
So in that case, then it doesn't seem like columns can be the standalone thing. It always ties to a data frame. I can't take a column from one. Most likely, if I take a column from one data frame and try to append it to another, it will fail because what are the chances that my row count's going to match?
But you can also build a column out of nothing.
Yeah.
As long as it
Yes.
has the right link, you can merge it in with
Yeah,
the existing
empty
data frame.
columns are fine.
So a data frame has to have columns of all the same length. Is that a mandate?
Yes.
Okay, and that's
It is tabular data.
You said empty columns are fine.
Yes.
So then,
Standalone empty columns are fine.
I
Or
see.
an empty data frame itself is fine.
I see.
so the length of the column is checked when the column is inserted into the data frame.
Yes.
Then? Okay.
Could it instead be some default value I can initialize the column with some default value that is the exact same length that I need for my current data frame?
There's the default capacity. It won't have data though.
You can build it with a numerable dot, whatever the thing is that just generates the sequence of the right length 0. Like now you have 500 zeros.
Okay, so can I set the capacity of a column
Yes.
to match my data frame's length that it expects and then add it?
No, it'll still throw. It needs to actually be filled with data.
Okay, the data count has to match.
Right.
Okay.
So the row count of a data frame can change, which is a bit strange to me, even though all of the columns have to have the same length.
There's no API for append yet.
No, but to append a column to a data frame?
No, to append a row to a data frame.
No, so if I call the data frame parameterless constructor, presumably row count is 0.
Yes.
And then if I append a column to the data frame,
Right.
presumably the row count has now changed.
Yes. For the first column, I allow that.
Can you
So-
remove a column from the data frame?
Yes.
What does row count return?
At that point,
After you remove the last one, it goes back to 0.
it should be 0. I'm pretty sure there's a bug now after you say that.
Well, because what I'm getting at is if you call the parameterless constructor for data frame, does it make sense to say like this is the row count that you are going to have and it's locked for all time?
No,
and
no,
any
no,
columns
no.
that get added have to match this.
No.
It's definitely not locked for all time. We want
Yes.
to have append row methods to this. You want to be able to build these things up as you go.
But what I'm saying is that okay, never mind, got it. Okay.
Row count will change, can
Got it.
change.
Yes.
Okay.
It just means at any given point in time, all columns
Yeah.
will have to have the same row.
At a snapshot, it's like that. Yep.
Okay. Because the other thing that I found a little strange is the constructor to data frame takes a list of columns, but the indexer is by row, not by column. So you have this mismatch between how the thing's constructed and how the thing is queried. Maybe that's intentional. It just seems strange to me.
Yeah.
There's also an indexer for the for a column and a row. So
Yeah.
where it says this long row index, that's the row indexer, and where it says
Yeah.
this string column name, that's the column indexer.
So that's one of my questions. It's like, you have two indexes, one that takes row index and column index, and you have another one that takes an enumerable of int.
Yes.
So if you
So
have two
5 index.
elements, that looks really weird now.
Your question is between long row index and enumerable int filter, right?
Basically between, how do I let this?
Yeah.
So this guy here,
Yeah.
if I pass this a two-element array, why is this different from passing things here? That seems weird. You know what I mean? Like,
Yeah, like what do the two filtery indexes do?
Okay.
it's probably the list of rows, right?
Right.
No, filter is by column. It has to be.
No, because the way I see it is that given that you have this guy here,
Yeah.
which is talking about rows, you're just invoking this effectively in a loop.
No, I mean
then-
filter
Then it would be
the.
an enumerable of longs.
Yeah, so that's why it has to be by column, not by row.
Oh my god.
So that's clearly a column. Yeah,
And that's, by the way, that type, the enumerable of t, is the only way that I could actually reason about that.
yeah, that seems.
yeah. I
So
don't.
what is the purpose of this indexer?
That one was to quickly filter stuff in a notebook. So if I had a data frame and then you wanted to filter out the first, like say 10,000 rows or something.
So this is about rows, not columns.
Oh,
Yeah, those
Definitely
are
is
the
about
rows.
rows.
It's not
The
columns.
enumerable
That's the wrong type.
index is the row. The index of the rows of what you want back.
Yes.
So if there's 100 columns or 100 rows, and you want the 5th, the 10th, and the 20th, you would pass in 5, 10, 20 here.
so that should be enumerable of
Yeah,
long then.
maybe
Right.
this should not be an indexer, and it should be select rows and take an enumerable of long because
Yes.
the rest of your row indexes are longs.
Range.
Like this.
Yeah.
This doesn't feel like the indexer is not getting smaller, which really suggests it's not. I mean, you're getting less data, but you. I can't think of a type off the top of my head where the indexer returns the same type.
Is it a common scenario that you already know the row indices you care about and you just want to select those very particular indices?
Well, I think in your case you
could
just
be.
say enumerable dot range, skip, probably, right? Or
We use it internally for sure.
Okay.
Yeah.
It
We use
could
it
be
internally.
like if
The
you sorted-
base column, the filter column, the one right above it, is super useful as well. Like this is, I have a column of booleans, true, false, true, false, true, false. That's selecting the rows that I want out of the data frame.
Right.
But I wouldn't turn
And then-
that into an enumerable though. I would just pass the actual mask back to you.
That's the one that's above the one that's selected.
Yeah, I think both of those. I think both of the indexers that are returning a data frame should be methods and not indexers, because you're not. While you are reducing the amount of data that comes out of this operation, you're not you're not getting to a smaller and smaller type. Like list of t goes to a t, string goes to a char because it's really list of char. It's set up, but using an indexer and then returning the same type as the type that the indexer's on feels very awkward.
I mean,
We would never have an indexer, on range that took a slice, or like a span has an indexer that takes a slice that returns
a span. Yeah.
I guess we said fine. We said the indexer that takes range returns the same t. But
these two things are ranges, right? These two things are ranges.
Yeah, I don't see it as all that different.
Yeah, how are they ranges? Because they are like iNumero long filter is a desperate. I mean,
that's
discontiguous list of.
That's a sparse
rows.
range.
Yeah,
we don't have one of those yet. You're inventing a concept.
Yeah, but if we had a sparse
same.
range, this would make sense, I think.
And if we had a sparse range and we were consistent across the frame, again, I look at this and if I saw something using the indexer, I would be baffled that it's what's coming back.
And with it being an indexer, you could never make this a params filter, for example, because then it's going to conflict with the long int overload.
Yeah.
Yeah. So just my recommendation is, this again feels like you're trying to be cute with operators and syntax, and this should just be a named method.
So Eric, can you go back to explain what the base column indexer filter does?
So imagine I have a 10 by 100 data frame, and I've built up some predicate thing that gave me a column of booleans, 100 long, and the trues are the records that I want to select out of the database or out of the data frame, and the falses are the ones that I don't want to select.
Oh my god, I get it now.
Yeah. So
actually, if you go to the unit test and do command F for filter, you'll see an example that does that.
So you're not returning a data frame that just has this one column.
It's a copy.
This one column just includes which rows do you want to keep.
Yes. Which is really, you have an IEnumerable bool here, and your column has to have Boolean data or bad things happen.
The IEnumerable int is more of like a convenience thing.
I mean the one of base column.
We're going to change the base column one. We said we were going to change that one because it's got to be a Boolean.
Yeah.
So that's the only way a filter would make sense. It's a Boolean.
Right. So the int one is it itself on the fly generates a predicate of effectively. It's the predicate of are you this row number?
Yes. Yes. It's an implied predicate.
So both of these.
So the base column one, if you remember that equality operators before we had the conversation returned a Boolean column. You can just take that Boolean column that you got back from the comparison operators and pass it into this indexer.
Right.
Right. And again, it's about writing compact code, right?
Yes, but again, the overarching guideline in .NET is it should be legible instead of it should be compact. We have specific guidelines that say prefer legibility over compactness.
Yeah, I mean,
it's why we call things divide instead of
in my opinion, it's legible.
Yeah, go for it, Eric.
Go for what?
You you were saying something.
You cut off.
I was saying, in my opinion, it's legible when you actually see it.
I think that goes back to expectations, right? I think if you're basically modeling what can be done in Python, right? And it just seems, if you're looking at the type combinations here, it just seems surprising. Maybe that's why we react this way. But I mean, if you have an expectation for what these things do, and then having compact notation is obviously fine. But I'm wondering whether people will look at those signatures and will be able to tell what these things are doing. Because, I mean, clearly in the room we had a lot of different opinions on what these things will do.
Because something like this can always be added later once there does seem to be a feeling that a lot of people are asking for it because a lot of people feel that it feels natural and stuff. You can always add things later. You can't ever take things away. And so these two, I look at them and I say they're not doing the same as the other indexers around them. They're not depending on something like range, which is we have the same pattern throughout the entirety of the framework, This is a different concept. So one of these would be like select rows, and another one would be like, filter. And those are the two operations, and they're not all, like, they're different. So we shouldn't be using the same syntax for give me this row, give me a thing that is logically like the set of rows but weird, and give me rows based on a predicate value. Like, just different names, so you help clarity. And again, you can over time you can decide based on usability that it's better to have this, and then you can add it.
But by the way, would it actually make sense to add a range indexer to this? I know range only goes up to int 32.max value, but I mean, if we have an indexer by row, then
that's one of the reasons for my index set proposal.
Yeah. I mean, it does kind of match.
Yeah, taking index is hard.
Taking index is hard, yeah.
Because
How do you have more than int-based rows, though? What's the backing store for a column? It's not an array?
Yeah, that's true. If this is all in memory, you can't have ever needed more than a int worth of rows.
Because
Doesn't have to be
it's
that fine, right?
it's stored as like chunks of memory.
Oh, sorry.
Each chunk is 2 gigs.
Yeah.
So a column could be
Fair enough.
Yeah.
Yeah.
Jesus.
I guess you
I
could.
pasted
And you could
something
have
in the
native
chat,
memory as well.
Emo. Can you open what I pasted in the chat?
I mean, and we have proposals to have things like long array and long span anyway, so.
Long index and long range.
Don't go there.
Okay.
The thread's still going on right now.
So in this case, like what this is doing, can you keep the line breaks? Is that? Well, whatever. So housing data in this case is a data frame, right? And so what this chunk of code is doing is it's splitting up 10% into a test data frame and 90% into the training data frame, right? So like the shuffle method, just you take in an int array and it randomizes it basically, right? So you don't worry about that. But what random indices gets you is a random, from 0 to the count of data that you have, all the indices randomized, right? And so, 16 and 17 is saying, take the test size of those random indices and split them up into two arrays. And now from housing data, so the key is 19 and 20, right? Like now from housing data, I can just say select out the train rows, and from 20, I can say select out the test rows.
Right.
So this also means that the data frame that you get back is going to have the rows in the same order that they were requested, not necessarily in the same order they existed originally.
Right.
Correct.
But
Yep,
like what,
in the IEnumerable of T, right?
Okay.
like looking through, the var here is good because it's testing what you think that the expression does. I'm good with up through 17. I think I have a good idea of what it's returning. 19 to me, I see housing like data of a thing. I don't know why it's taking multiple rows, but to me it's returning like one thing. So train must be a row, or maybe it's a column. But like
What
I
train
have
rows
no
is.
neural.
You said up to 17. You know what everything up to 17 is.
Right, and then I look at 19, and now I need to go like I need someone to expand this var because I have no prediction of what that type is.
Well, what's train rows?
It is a collection of rows, whatever that means. It could be a list, it could be a data frame because a data frame is a collection of rows, but I don't care. It's a thing that has an indexable number of rows.
Yeah, train rows is an int array. Test rows is an int array.
Yes.
Yes, which is different from what you
That's
said.
not what Jeremy
Yeah.
said,
Yes.
right?
Yeah.
Right. So
But once you know it's an
if,
now
array,
it's
if you don't know what the var does, if you can't look at the code and guess what the var does without knowing, like without super knowing what the type is, it means that you're abusing an indexer. So, like,
But you didn't know what 16 was.
I thought I did. Apparently, I was wrong.
It's an int array.
I mean, if we follow the guidelines anyways, you're not supposed to use var here, even though I would use var.
Well, that's the core FX guidelines.
well, but it's on a notebook. You just press shift enter and you know what train rows is.
But this is not a notebook feature. This is a .NET feature. You
I
can
mean-
use it in notebooks. You can also be reviewing code someone wrote for other purposes.
I would just push back for that by saying the indexer, I assume, my expectation is it will be used mostly in the notebook, and when you have IntelliSense in the Spark Visual Studio, then you can use any method name you want because you know what it does.
Oh, right. Sorry, I got the train rows wrong because I didn't pay attention to the variable that was on the left. I thought it was the data frame that was being indexed with the range syntax.
I see.
But yeah,
So removing the var, because I actually hate var as well, gives you this.
But
Can you paste that in there, Emo?
Does that mean you would keep it as IEnumerable of int, or you would make it IEnumerable of long?
The only reason I put int is because I could not make an enumerable.range, but that returned an enumerable of long. It only returns an int.
Yes.
IEnumerable of int.
Correct, but I mean you're designing an API for something that is intended to hold potentially more than 2 billion rows, and now you're saying that this particular indexer can only access up to 2 billion?
So I just think line 20, if it said housing data.select rows, train rows, would be way more clear than using the square bracket notation.
I would agree with that.
Then why didn't we do that? Then why didn't we do that for random indices of square bracket test size ...
Sorry, what was that?
This one?
Why didn't we do it for 17 then? Why didn't we make a method on for 17?
If you're like, I mean, this
because-
isn't selecting random; it's selecting contiguous. But sure.
Could be random.
Well, I guess I don't understand why that makes a difference.
So again, for one, this is the type range that we added. For better or worse, we came up with guidelines of what it does, which is that it does return the T. A lot of people were upset with that, which is why I deleted that fact from my brain. And so this is a pattern that we already have that we have it. The inventing a new thing based on IEnumerable that has a similar feel, again, we're inventing a concept.
And I was
I don't
advocating
think-
having a range indexer.
I don't think we are. This is still range indexed. It's just multi-dimensional range indexing, which range does not support.
It's not multi-dimensional though.
It's still technically a form of multi-dimensional.
Well, if that were true, then I would say the array itself, the elements of the array, would represent the dimensions that you care about.
I think it's just discontinuous.
Yeah.
Yeah, it's discontinuous.
Yeah.
Yes, this
But
is a-
but yeah, so like array already has a range indexer. Like I would be totally fine with DataFrame having one. Like it kind of matches.
Yeah,
what else
again,
we
I
got
understand the
right
one for system.range.
Yeah.
It's when we're inventing new things like the predicate column and the give me these row numbers that I just think it's more clear that these things have words. I think it would be way more clear if our range thing, we didn't use the square bracket notation either, but I lost that argument.
Yeah.
But the reason we did is because it's more natural for people to write this code.
So it sounds like the better way to write this code, honestly, would have been housing data.select, and then inside of your select predicate, just choose a random number between 0 and 1. If it's greater than 0.1, return false. If it's less than 0.1, return true.
The problem is you still then have to manually think to yourself, where does indexing fall in the order of operations as compared to every other operation? And you have to manually say, I have to rearrange my expression now to put indexing here so that it occurs at the right location in relation to everything else.
Levi, your example doesn't do exactly what this does either, because
doesn't, no.
this gives me exactly 10%.
No, and mine gives
Yours will
statistically
give me exactly
10%.
Yeah.
Yeah.
Yeah, and yours, you didn't need to figure out how to build the negative filter for getting the other one. This one's built it a priori, so it knows that they're different. But
Yeah.
I mean, I think so. The one thing I think where it differs is that range is a very specific type, and so saying an indexer that takes range has a certain behavior, I think, is one thing. The problem of IEnumerable is that it's already an existing type used in a billion other places, and that seems like a weird combination. I think if you would have had a discontiguous range somewhere, saying that a range-based indexer has that same behavior as a range-based indexer seems reasonable to me. I'm just not sold on the IEnumerable thing, because to me, in IEnumerable, the problem is it's logically a collection, right? And so that to me is almost the same as multiple parameters you pass to the method. That's why I'm saying if you have one indexer that takes A and B, and then you have an IEnumerable that takes an int, how is that different from a two-element IEnumerable with the other overload that takes 2 elements. That seems to me the bigger problem.
The solution to both problems is have a name method that says like select rows, and you take in the INumerable and in this case log.
Well, either have a name method or make it very clear in concepts, right? So, for example, we don't represent a range as loose to ints. So it seems reasonable to me to say if you have an overload that takes one long, one int, and if another overload that takes a range, there's not really a conflict what they do because they're completely different concepts. The fact that they're baked by similar types is almost irrelevant.
The overload that takes a range would fail if the collection is greater than 2 billion elements.
Well, there's that. But there's also you don't want it contiguous, right? All I'm saying is the difference really is that the type makes a difference, in my opinion.
Right. The majority of .NET code that takes a range and that takes 2 ints is going to end up being almost equivalent because range is new, and so people wanting it would have been doing start length for manual range previously. So that's probably another concept count that has to be considered.
Yeah.
I mean, it still might make sense to offer a range though, because if your collection is smaller than, what is it, in max value, which seems reasonable, but at the same time, because basically what you gain is you gain the language syntax, right?
Right.
But now you have an abstraction where certain syntaxes don't work.
Yeah, I don't know if we should support range if the backing type is long.
If 99% of the usage is beyond that
So
seems
first,
reasonable.
like Essen said, first off, we don't know if that's true.
Yeah.
Second off, do you actually know if you're in that world with any type of reliability? Like if you're used to writing code that works 99% of the time, and then just by muscle memory you type it for something that it's not intended for.
I mean, if you make a thing that takes range instead of using the rangeable pattern or whatever they did, then you can see the thing that it did the dot trail off, and you can yourself look at the index and see that it's counting 5 from the end. Right. Yeah. They can hook it themselves and turn it into a long concept. They don't have to call range dot.
It doesn't give you the full granularity of what you would expect from range, but that's a problem. You wouldn't be able to reference things in the middle of the collection.
There are things that you wouldn't be able to express.
Yeah.
But you're going to get that when you try and take whatever thing you got that was a long index and build the range object out of it. Either you had ints and you were working with them, or you cast the belong to an int yourself, and that's a sign of something might go wrong here.
No one ever uses checked blocks. There's not a checked block being used in this sample.
Well, and multiplying by 0.1 is going to give you an inexact result with rounding error. Should be divide by 10, and then accounting for midpoint.
Sure.
All right, so we are out of time, but we're also nowhere near done. So,
when you're started though.
So there's another 2 hours probably we should spend on walking the remaining API surface. So my question is more for Eric and do you have enough to work off of, or do you need another review soon?
I mean, the goal I established was I want a preview of this API on NuGet.org by Ignite. That's a month.
So to me, the one thing is, I would generally say a preview should be barred on what the feature team feels is appropriate, right? I don't think we have to resolve all issues in order to ship a preview. In fact, there are probably many questions we just had where, it's interesting to see how customers react to that, right? What feedback do you get, right? So
especially if we have something and then take it away. We probably hear it if somebody liked that or wants
sure,
it,
but
right?
that's the notion of every preview. So, we've done this across the board. That one I'm less concerned about. That's more
I'm not concerned about it. I would be happy.
Yeah,
I would be happy if we had something, took it away, and then somebody said, "Hey, I was using that, and it's really great in this scenario." Then we know that it's useful, right?
Well, and
sure.
we shipped the ARM64 intrinsics as experimental, and we've completely changed how they're exposed for .NET 5. So it's not unprecedented that we ship experimental package and then change everything underneath people.
Right. I'm totally fine with continuing it past a preview. The point was doing this before the preview stage to get the major kinks worked out, right?
Yes.
This shouldn't be called base column, right? That are pretty, pretty major but obvious, right?
Yeah, I think the one thing we should probably close on for Ignite is what's the package name and the namespace name, right? That seems something that changing those later is always annoying because you can no longer talk about what it is that you shipped and how it relates to this other new it.
Especially when we ship packages matching the name of the namespace.
Yeah.
And so my feedback on that is if this is very, very transparently built on Arrow,
Yes.
that Arrow should be in the namespace somewhere. Or like it shouldn't take Microsoft data because it's not the be all and end all of data. It is Arrow compatible data. Like it's, and maybe everything's Arrow compatible data, but like if a new standard comes along tomorrow and we're like, oh, that one's better than Arrow, we want to do that. Oh, damn, we took all the good names already. Like,
But the opposite to that is if I had a generic name and then we decided to change out the Arrow implementation, then I wouldn't have to change the name or the package.
if you didn't expose the fact that it was Arrow data at all, then you could use the generic name.
Yeah, which nobody knows that it's Arrow.
You had a constructor that took a thing that you said was from Spark
record
or
package.
Arrow or something.
A constructor, that's it.
No, that means this type is now concretely linked. Like you have linked it together. It is in the public API. They are the same. You cannot change that detail now. You could write a conversion on it, but then you're going to get whatever massive performance penalty you get from being transparent to converting. So you're never going to do that.
But you would be okay if I had an extension package that did the Arrow interop.
Sure.
And then you would be okay with having a generic namespace.
Because then this type, when you're using this type, it has nothing to do with Arrow. The import is not from Arrow. The export's not to Arrow. That's all something else or derived types or whatever.
Okay, that's easily solvable. Look,
Right.
consider that. Okay, cool.
Right, so that's if you want the data frame to be a generic data frame, get rid of all the arrowness. And then make an Arrow data frame that extends it. That's fine.
Okay.
But it's don't link Arrow into it and then call it something generic like Microsoft data.
So maybe, Mr. Webb, what is the arrow tie-in here?
Record batch or was a custom
Record batch is the so it's the only.
I mean, the real tie-in is one that it's columnar, right? Like this thing is definitely a columnar backed data frame.
So what does that mean?
And then-
You mean it's column order? Is that what you're saying?
Well, columns are its
It means
primitive
the data
instead of
is stored. It means the data is stored in column order. So
Oh yeah, okay.
like if I have two columns, column A, all the things in column A are together.
Sure.
And then column B, all the things in column B are together. I don't have A, B, A, B, A, B interspersed.
I would say, okay, that's a specific characteristic of what we have here, but it's also relatively generic, where there's multiple column stores that exist in the world, because for data density, it just makes sense, right? Like,
But then the other thing is, we do expose like things like the null bitmap, right? Which is saying, which is like a next step closer to exactly what Arrow specifies.
It's not in the public APIs though.
It has to be if we're exposing the backing data
Only
as a
when
buffer.
You,
You need the null bitmap then.
Like, because you have the string type somewhere that's going to take the null, like the multi-SZ in the Arrow format.
right.
Like, that's an Arrowism, so that should not belong in your API. That's an Arrow string. That's not a string. That's not a data string. That's an Arrow string.
Okay.
So it's if you're taking anything is based on, oh, you can see how you build this by looking at Apache Arrow's website, then that's an Arrowism and not a data frameism. If you're designing it and it looks like it, and you're okay with the notion that you've copied their behavior, but it's if some other thing came along later that everybody else was doing and we thought was good to do too, I'm not just saying bandwagon, but like it had value. If we're now going to have, oh, we want to go change an internal implementation detail, we're not using Arrow string anymore. Oh, but we export as Arrow string. Okay, this went from a like non-transformation based copy to a transformation copy, or
Right.
this went from we gave you a span over the data because it was free to we're making a copy to give it to you now. Like these are very big changes, and anything that would ever require that for switching off of Arrow, either this type is an Arrow data frame, or they need to be moved out to a derived type.
So are you planning on writing your notes before you end recording?
So what?
Before we stop streaming, are you gonna publish your notes?
Why would I publish them before I end streaming?
Okay, never mind.
It seems like a
Minutes get
very
published after the meeting.
It's
You
a
can't publish
complicated
during
thing.
the meeting.
No, I mean, like I will publish them as a one-off thing in the API reviews repo, right? Because this is not the normal triage.
The
thing.
Arrow guys themselves would make a data frame.
But I think I will now end
But
streaming
most
because I think
likely
we're
don't
done
care
with
about
that.
Yeah. I'm like, that. I mean, my guidance is.
Bye, folks online.